Welcome to part 2 of domains and ranges. Now, we looked at it graphically before. Now we're just going to be looking at domains, and there's a couple things that are bad with domains. You can't divide by 0, so we don't want to allow this function right here to have any value that gives us a 0 in the denominator. So what we can think about is this. X minus 3, that cannot be equal to 0 because we can't divide by 0. That's undefined. So we can solve this just like we can a regular equation by adding 3 to both sides. And that means that x cannot be equal to 3. Which makes sense. If we plug 3 minus 3 is 0. So that is the point that's not defined in the domain. Now, when we talk about this, we can talk about the domain. I'll write this down here. So the domain of this, we can think about it as all values except x cannot be equal to 3. Another way of saying this is it can be from negative infinity to 3, not including 3, and then again from 3 to infinity, which breaks this into two intervals. You could think about it like this, like there's the value 3, that's going to be disallowed. We want everything over here, which that corresponds to that interval. We want everything over here, which corresponds to that interval. So that's another way to think about that. Okay. Now, this next one here, if we look back up these instructions, it's no zeros in denominators and no negatives under even index radicals. So like square roots is what that's saying. Now, here, are there any denominators? Well, there's no denominator. Is there any radical sign? No radical sign, so the domain is all real numbers. So we can also think about this all real numbers as an interval, and that's the interval essentially where the whole number line is shaded in, so that's from negative infinity to infinity. And this actually corresponds to the first graph on the last page if you look at that. Now, this next one here, this g, we can't have a 0 in the denominator. So 4x minus 3 cannot be equal to 0 because we can't have a 0 in the denominator. We can't divide by 0. It's undefined. So solve this like a normal equation. Plus 3. 4x is not equal to 3. Divide by 4. And we get x is not equal to 3/4. And notice if you plug that back into there, 4 times 3/4 minus 3, that's going to give us 0. So we can say this is the domain. We can also write it in this interval like we had before, but now the point that's missing is 3/4. So it's from negative infinity to 3/4 and 3/4 to infinity. Okay. Now the last one here, we have the square root of x plus 5. Now you can't have negative numbers underneath the square root. So if something's not negative, it has to be greater than or equal to 0. So what we can do is we can solve x plus 5 is greater than or equal to 0. Solving this, subtract 5 from both sides. And we get x is greater than or equal to negative 5. So that would be kind of the set notation would be that. If we're thinking about the interval here, well, this is going to have a graph where we're at negative 5. And we're going to fill that in because we have greater than or equal to, and because we have greater than or equal to, we're shading this way. So this would correspond to the interval that starts at negative 5 and includes negative 5, so we want a square in bracket, and goes to infinity. So that's kind of looking at domain from a function notation and an algebraic standpoint. The previous page was graphic. So hopefully it made sense, and see you next time.